can now discuss a few things here. That is, let us take some examples. So, example number one. Example number one will be that let us take one more function here with us, that is fx is equal to x square minus 1 upon x square minus 3x plus 2, and x is not equal to 1, that is one of the things, and is equal to 2 whenever x is equal to 1. Clearly we can say the function is not defined. Whenever it is x is equal to 1, it is this, and not equal to, then it is different. Means the RHL will be different, obviously. Function says that it is not equal, whenever it is not equal to 1, it will have a different converted form. Function is there, the function value will be equal to 2 when x is equal to 1. It means that at any other points like LHL, RHL, it will be different value than 1, than 2. That's why it is not defined. Okay. The last case, when we said that the function is defined, we calculate the value as 2 to be 7, and LHL value in the last case was approaching to 7, that is slightly less than 7, but it was approaching to 7, and from the RHL also it was approaching to 7. So let us understand about this case in more detail. Function is not defined as x less than 1, LHL and RHL values are different, than x is equal to 1. So this is the one of the case. Now if you just calculate the LHL here, let us see the left hand limit in this case. LHL, left hand limit. So limit x tends to 1 minus, for that we have x square minus 1 upon x square minus 3x plus 2. Whenever we are removing the 1 minus, we are removing it with h is equal, h tends to 0. Okay, h tends to 0. So here it will be 1 minus h, 1 minus h whole square minus 1 upon 1 minus h whole square minus 3, 1 minus h plus 2. Further, this will be limit h tends to 0. Okay, and what it will be, let us see. So 1 plus h square minus 2h minus 1, 1 plus h square minus 2h minus 3 plus 3h plus 2 and limit h tends to 0. This will be h square minus 2h, and it will be h square plus h, and obviously so h can be cancelled out because h is a value which tends to 0, not a 0 value, right? So this can be cancelled out easily. H tends to 0. H minus 2 and h plus 1. So this can be cancelled out. H tends to 0. And further this will be h minus 2, h plus 1. Whenever h tends to 0, this will be leading to minus 2 and 1, which is equal to minus 2. So LHL value implies that LHL value will be minus 2. Okay. Now let us see the RHL value. Right hand limit will be limit x tends to 1 plus x square minus 1 upon x square minus 3x plus 2. Now whenever left hand limit, whenever saying it is 1 minus, in that case we are removing it. In that case we are keeping h tends to 0. Okay, and we are writing 1 minus h. In the case of RHL, 1 plus it is, so it is 1 plus h we will write here. Okay, that is fine. Yeah, so let us understand this. H tends to 0, which will be h plus 1 whole square minus 1 upon h plus 1 whole square minus 3 h plus 1 plus 2. Now so in the same fashion, if we will be trying to do one thing, that is h square plus 1 h square plus 1 2h minus 1 h square plus 1 plus 2h minus 3 plus 2 limit h tends to 0 h square plus 2h square minus h, and this will lead to obviously limit h tends to 0. H can be cancelled out because h is tending to 0. It's a very small quantity which tends to 0, right? It is a value. So we can say here h plus 2, h minus 1. This will be cancelled out and this will become as 2 minus 1, that is minus 2 is the answer here. So answer for LHL, RHL are same. We agree with this. It implies that we can say here LHL is equal to RHL equal to minus 2, but function at 1 function at 1 is 2, hence function has a limiting value. Function has a limiting value at x tends to 1, but is not defined. If you consider some other function the same similar fashion, here we can take some other examples where function will not be defined. Right, the case is function behavior is having a limiting value at h is equal to as x tends to 1. It is a limiting value, but it is not defined. And why it is not defined? Because value of function at 1 is 2, which is different than the limiting value. But there can be other cases where the function is not defined, that is LHL is not equal to RHL is also a case. Existence of function at, so that part we will try to understand. Okay. So existence of function. Right now we're going to discuss existence of limit of a function at x is equal to a. Existence of limit of function as equal to a the limit of a function fx at x is equal to a exists if limit x tends to a minus fx is equal to limit x tends to a plus fx, limit x tends to a minus fx is equal to limit x tends to a plus fx, or limit h tends to 0 f e minus h is equal to limit h tends to 0 e plus h, function of that. That is LHL is equal to RHL. LHL is equal to RHL is equal to at x is equal to a. It is evident that for limit to exist, function need not to be defined at x equal to a. So obviously limit can exist, it can have a value, limiting value, but it is if it is not defined, that is also fine with us. If function fx is single definition function which is defined at continuous x equal to a, then it is not required to find both respectively. If function fx is single definition function which is defined in continuous at x is equal to a, then it is not required to find both limit a minus and a plus fx. We can find limit fx x tends to a, limit x tends to 0 cos x is equal to 1, and limit of example, we can take here some examples like limit x tends to 0 of cos x is equal to 1, and limit tends to 1 of x plus 2 x square plus 1 3 by 2. So this can be done like this, and yeah. Okay. So the session is on pause for some time.